Hello, everyone. I know it's almost lunchtime, so let's get started quickly. Welcome to my presentation, and I'm very happy to be here. This is my first time to join the ROS conference. I'm very honored and excited. So today, my name is Minggang, and I'm a software engineer from Intel. I'm going to show what we have done on ROS2. To be specific, what we have done to make ROS be more friendly to web. We have done two packages to make it possible to integrate web technology into ROS. So why do we want to do that and how? Let's go to the next page. Okay, this is the agenda. A bunch of items. Looks like there are a lot of contents, but I promise each page would be simple and straightforward. I'm going to talk about who we are, why we choose Node.js client, what developers can benefit from it, and what we have done to make it happen. There is also a high-level design principle and architectural design, a complete feature list, and a video demo to show you what the idea is. And also I'm gonna talk about the performance because as we all know, performance is always important. So let's get started to the very first one of the real pages. So like I said, I'm from Intel and I'm a software engineer. When Intel is mentioned, I believe chip is always uppermost in the minds of people. But there are a lot of people like me are doing software development in Intel. And we have contributed to many open source projects, big or small. For example, Intel is the top one contributor to Linux kernel for years. So I guess you are familiar with the brands and the logos on the bottom of this page, like the Linux operating system, the Chrome browser, and the Android. The OTC contributes to these projects a lot. As I'm from the web team of OTC, we do web technology in every layer of software where it's necessary to do so. We want to make sure web is open, secure, and runs in good performance. So I highlight two logos here, the ROS2 and the JavaScript. So my presentation is all about the combination of these two. So why do we use Node.js and the web in ROS? JavaScript was initially implemented on client side running in a web browser. But after Node.js was invented, everything changed. It enables developers to write server-side code to be a full-stack developer. Node.js itself is built on Google V8 engine, featuring event-driven programming and hard concurrency. For the benchmark on the right, we can see the Node.js is faster than most of the script languages in most cases, which means you can do more by the same hardware within a certain time. For the ecosystem and the influence, JavaScript has the largest amount of pull requests on GitHub. You can see another diagram on the bottom. The NPM, which is the package manager, it hosts hundreds of thousands of packages covering most of your requirements. So the Node.js apps are easily deployed. Next, I'm going to talk about some ideas we want to deliver about ROS on web. Okay. Web is always the first solution you come up with when you want to have a dashboard or a remote control UI, because it's easy, powerful, and a cross-platform. But when it came to ROS2, there was a problem. The ROS bridge, it's one of the key component of robot web tools, which was designed for ROS1 but not compatible with ROS2. And there was no solution available back in the mid 2017. So we kicked off and said we want to do a new bridge for ROS2. Here, I'd like to give special thanks to Ji Hong, one of the owners of RWT, who was very kind. He helped us to create a new repo and make us as the owner. Here, I'm assuming you know the ROS bridge is a bridge on the server side to expose major ROS1 features in a web browser. So the web developers can write dashboard or visualize a robot in a browser. We investigated the ROS bridge and find out it would be easier to write a ROS2 bridge if a Node.js client were already there. So with this thought, we actually enabled a new approach to bring ROS to web using Node.js web server plus browser. We can integrate the ROS capabilities into the web browser as services, which will isolate the information and only review the ones that the UI needs. And the web browser is the only one who can talk to ROS. And the browser only knows the business logic. Thus, none of the ROS API is exposed inside web browser. We call this solution is robot as a service. The RAAS supports more healthy usage. Say, if you write a ROS service in a browser, what's gonna happen after you close the browser? All clients depending on that service will wait forever. And this won't be a problem if you write a service on the server side. So let's go to the next page to see what we have done so far. Totally, we did 2 packages, and both of them are hosted on the RWT GitHub. The first package is RCL Node.js. It's a Node.js client for ROS2 based on the RCL library and has the same functionality compared with Python client. And the second one is ROS2 Web Bridge, which enables developers to talk to ROS2 from browser. It uses the RCL Node.js to interact with ROS as backend and implements the ROS bridge protocol to communicate over WebSockets. Here I listed some important milestones. The first prototype dates back to May last year, and the beta release finished after the first stable release of ROS2. As both of the 2 packages are built against the master branch of ROS2, we keep up closely with the latest changes and features. Okay, here I'm going to show some principles in design we followed during the implementation. In the era of ROS1, if you want to implement a client of ROS, you have to start from scratch because there was no middleware. But now we have the RMW layer in ROS2 and the RCL library on top of it. So as the RCL library is written in C language and implements the behavior of ROS concepts that are non-platform specific. So we use Node.js to wrap it and to make it as fast as possible. An advantage of Node.js solution is that it's asynchronous ROS, so the main thread never gets blocked. We also take the advantage of those in ROS programming. You can use promise to wait for an upcoming notification to take further action. And also we decided to integrate the ideal generator in our project. So you don't have to run the generator to generate the source code of the messages, which is more convenient. And debugging, it's very important to developers. User-friendly debugging can dramatically shorten the cycle of development. Node.js is famously known as easy to debug, and we also added some extra facilities to help developers to debug in RCL Node.js. The diagram on the right shows the framework of RCL Node.js. The red part is the Node.js main thread. The red part is the worker thread, which pulls the events from the RCL library in background. So, and the horizontal line separates the JavaScript from the C++. We bind the C interfaces to the JavaScript side. As a result, we can write a ROS app in a very easy and effective way. You can see the code here is only 9 lines to create a node and to construct a publisher to send a topic of string type. All right, let's move on to go through the framework of the web bridge. Overall, the bridge is compatible with the protocol of ROS1. It's fast, simple, and written within a small amount of code. This diagram shows the whole picture that how browser talks to ROS by the RCL Node.js client. When talking to ROS through ROS libjs, which is a JS library running in browser, the command will send to the server over WebSocket. The data format complies to the ROS bridge protocol. When receiving the data, the bridge will extract its operation code, which indicates the wanted action, and map it to the corresponding JS interface. Hence, the workload of the bridge is pretty lightweight. It acts as a proxy to delegate the command to the Node.js client. So what can we do with RCL Node.js? Let's catch a glimpse of the main features. In summary, the RCL Node.js has a comparable feature set to the Python client, such as the ROS node, the publisher, subscription, etc. And here I'd like to point out the action leap. We collaborated with Chris, who is from Rethink Robotics. Through migrating the Action Leap Node.js module, we integrated and exposed the client and the server interfaces through ROS node. I think the RCL Node.js is the first one to implement this feature. Beyond the features here, we also did performance benchmark on different ROS clients. here we compared the three clients, the C++, Python, and Node.js. The test case here is to publish topic with large binary data. And the diagram below shows the time and the memory consumption when running the test case. From the left column chart, we can see that the Node.js client took longer time than the C++, but close to it and much more ahead of the Python client. It's about 2 times faster. And the red column chart shows the memory consumption. It's no wonder the C++ is the best. And the price we have to pay to get a faster Node.js client is more memory consumption. So my suggestion is that if you want to achieve a good balance between performance and flexibility, Node.js is a better choice. Here comes the demo session. It's a very similar one to the previous. The demo illustrates a common scenario for the usage of the bridge. The hardware platform compromises a Turtlebot 3 and upboard running the ROS2 and the bridge. And here I'd like to give thanks to Pew. I hope I read it correctly. He was very supportive and gave us a lot of help to set up the demo on ROS2. Okay. Through the video, we can see the left part is a web page running on an Android tablet, and the right part is the Turtlebot 3 platform. And by leveraging the ROS-libJS and the ROS2D.js, we can control the motion of the Turtlebot and visualize it through the ROS2D.js in the browser. And you can run the web app wherever there is a browser. And you can also get a simple demo on our GitHub repo. The previous pages are all about the contribution to ROS done by our team. And on this page, I have listed other Intel open source projects that I have known. So let's take a quick view of these projects. There are ROS service and bridge about AI, machine learning, computer vision, publisher of dedicated AI hardware manufactured by Intel, and the publisher of a 3D camera made by Intel, navigation stack for ROS2, and there is also an open source robot. You can see the picture on the right. It's open source both in hardware and software. These pages show some code examples of some common usage in RCL Node.js, like publish a topic, send a request to a service. You can see it's very simple and easy, very few offline. And how to write a publisher in a browser. And you could contact me through the email. I put some useful links in this page, which includes some packages either for ROS1 or ROS2 and packages from Intel. I'd like to thank all the team members for their dedicated work. That's it. Thank you for your time.
We'll take one quick question over here.
Thank you. I just wanted to say that we use this ROS bridge extensively, and we find it really useful. But I have a question. It works well with the messages relatively small size, but if you need to send lighter information or image, there are some issues with performance. Do you plan to optimize it or to do something extra to make it work faster?
To my point of view, if you want to use the bridge, I think the performance is a problem, as you said, because it's the transport is over the WebSocket and in JSON, so it's hardly to improve the performance. I suggest you can, if you use the web solution, you can use some web standard protocol, like use the video tag to streaming the video to the web browser instead of transfer it through the bridge.
Okay, thank you very much.